Open bottom junction boxes are not specifically addressed by the National Electrical Code. The 2023 National Electrical Code contains Section 314.29. That states in part conductors entering a raceway other than at a terminal point shall be protected by a fitting designed for the purpose. Equipment, such as switches or controls, shall be provided with a fitting designed for the purpose. The fitting shall be of such design as to secure the cable or raceway firmly in place and shall be listed for the application in which it is used. Precast concrete transformer pads do not provide a fitting to secure the cable or raceway. In addition, the box has an open bottom. Since the National Electrical Code does not address open bottom junction boxes, equipment installed in this type of box must be suitable for the location. Transformer pads are installed outside and often contain moisture. Therefore, THHN conductors spliced and left loose in the bottom of a transformer pad are not code compliant. If a transformer pad is to be used as a junction box, it should be modified with a watertight fitting or enclosure to secure and protect the conductors. PVC boxes with listed covers are suitable for this purpose. Let's delve deeper into the issue of open bottom junction boxes and their compliance with the National Electrical Code. While the code doesn't explicitly define or address these types of enclosures, its general principles and specific sections offer guidance on how to approach such installations safely and in accordance with regulations. The core problem stems from the fact that open bottom junction boxes lack a complete enclosure, which raises concerns about environmental protection, physical security, and overall safety. The absence of a bottom exposes the internal components, such as conductors and splices, to the elements, including moisture, dust, debris, and even rodents. These environmental factors can degrade the insulation of conductors, leading to short circuits, ground faults, and potential fire hazards. Furthermore, the lack of physical security makes the installation vulnerable to tampering, accidental damage, or unauthorized access. To address these concerns, the National Electrical Code emphasizes the importance of using equipment that is suitable for the specific environment in which it is installed. This principle is particularly relevant to open bottom junction boxes, as their open design inherently exposes the internal components to the surrounding environment. Therefore, any equipment installed in such a box, including conductors, splices, and connectors, must be rated for direct burial or for use in wet locations, depending on the specific conditions. In cases where standard wiring methods, such as THHN conductors, are used, additional measures must be taken to protect them from the environment. This can be achieved by installing the conductors in a conduit system that extends into the open bottom junction box, providing a physical barrier against moisture, dust, and debris. The conduit system must be properly sealed to prevent the ingress of water or other contaminants. Another option is to use a listed enclosure with a cover to protect the internal components of the open bottom junction box. The enclosure must be rated for the specific environment in which it is installed, such as a wet location or a corrosive atmosphere. The cover must be securely fastened to the enclosure to prevent unauthorized access or tampering. In addition to environmental protection and physical security, open bottom junction boxes also raise concerns about grounding and bonding. The National Electrical Code requires that all metal enclosures be properly grounded to provide a path for fault current in the event of a short circuit or ground fault. This grounding system must be continuous and effective to ensure the safety of personnel and equipment. In the case of open bottom junction boxes, the grounding system must extend to the enclosure and any metal components installed within it. This can be achieved by using grounding bushings or lugs to connect the grounding conductor to the enclosure. Furthermore, all metal components within the enclosure must be bonded together to ensure that they are at the same electrical potential. This bonding system can be achieved by using bonding jumpers or other approved methods. It's important to note that the specific requirements for grounding and bonding can vary depending on the voltage level, the type of equipment installed, and the specific application. Therefore, it's essential to consult the National Electrical Code and other relevant standards to ensure that the grounding and bonding system is properly designed and installed. In situations where an existing transformer pad is being repurposed as a junction box, it's crucial to assess the existing conditions and make any necessary modifications to ensure compliance with the National Electrical Code. This assessment should include an evaluation of the environmental conditions, the physical security of the installation, and the grounding and bonding system. If the transformer pad is not suitable for use as a junction box in its current condition, it may be necessary to make modifications such as installing a listed enclosure with a cover, providing additional environmental protection, or upgrading the grounding and bonding system. Alternatively, it may be necessary to abandon the use of the transformer pad as a junction box and install a new code-compliant enclosure. In any case, it's essential to consult with a qualified electrical contractor or engineer to ensure that the installation is safe, compliant, and meets all applicable codes and standards. The National Electrical Code serves as a comprehensive set of guidelines for electrical installations, promoting safety and standardization. While open-bottom junction boxes aren't explicitly addressed, the code's fundamental principles guide their proper implementation. Firstly, the environment plays a crucial role. Open-bottom boxes, by their design, expose internal components to the elements. This necessitates that all equipment within, including conductors and splices, be rated for the specific conditions. If standard wiring like THHN is used, a protective conduit system extending into the box can act as a barrier against environmental factors. This system must be sealed to prevent water or contaminant ingress. Secondly, using a listed enclosure with a cover becomes essential. This enclosure should be rated for the environment and securely fastened to prevent unauthorized access. Proper grounding and bonding are also paramount. The National Electrical Code mandates that metal enclosures be grounded to provide a fault current path. In open-bottom boxes, the grounding system must extend to the enclosure and metal components within, using grounding bushings or lugs. Bonding ensures all metal components share the same electrical potential achieved through bonding jumpers or other methods. These grounding and bonding requirements vary based on voltage, equipment type, and application, necessitating adherence to the National Electrical Code and relevant standards. When repurposing a transformer pad as a junction box, a thorough assessment is necessary. Evaluate the environmental conditions, physical security, and grounding system. Modifications like installing an enclosure, enhancing environmental protection, or upgrading the grounding system might be required. If the pad is unsuitable, consider abandoning its use as a junction box and installing a new, compliant enclosure. Consulting a qualified professional ensures the installation is safe, compliant, and adheres to all codes and standards. Here is a breakdown of considerations when dealing with open-bottom junction boxes. Firstly, assess the environment. Determine if the location is wet, damp, or dry. This will dictate the type of protection needed for conductors and other components within the box. Secondly, consider conductor type. If using standard conductors like THHN, ensure they are protected within a conduit system extending into the box. Seal the conduit to prevent moisture or debris ingress. Thirdly, enclosure selection is crucial. Choose a listed enclosure with a cover rated for the environment. The enclosure should be large enough to accommodate all conductors and splices comfortably. Fourthly, grounding and bonding are paramount. Ensure the enclosure and all metal components within are properly grounded and bonded according to the National Electrical Code requirements. Fifthly, physical protection matters. Consider the risk of physical damage to the conductors and components within the box. Provide additional protection if necessary, such as barriers or guards. Sixthly, accessibility should be maintained. Ensure the box is accessible for inspection, maintenance, and future modifications. Seventhly, local codes may apply. Check with local authorities for any specific requirements or restrictions regarding open-bottom junction boxes. Eighthly, professional consultation is recommended. If unsure about any aspect of the installation, consult with a qualified electrical contractor or engineer. Here is some additional clarity on conductor types and their applications within open-bottom junction boxes. Firstly, THHN conductors are commonly used in conduit systems. When used in open-bottom junction boxes, they must be protected within a conduit extending into the box, as mentioned before. Secondly, THWN conductors are suitable for wet locations. They can be used in open-bottom junction boxes without additional protection if the environment is consistently wet. Thirdly, XHHW conductors offer high heat resistance and are suitable for wet or dry locations. They can be used in open-bottom junction boxes without additional protection in most cases. Fourthly, direct barrel conductors are specifically designed for underground installations. While not typically used in open-bottom junction boxes, they can be used if the environment is extremely harsh or corrosive. Additionally, consider these points regarding the use of fittings and connectors in open-bottom junction boxes. Firstly, use listed fittings and connectors that are suitable for the environment. Choose fittings and connectors that are made of corrosion-resistant materials if the environment is wet or corrosive. Secondly, ensure that all fittings and connectors are properly installed and tightened to provide a secure connection. Thirdly, use watertight fittings and connectors if the environment is wet. Fourthly, consider using strain relief connectors to prevent stress on conductors. Here's how to properly seal conduit systems in open-bottom junction boxes to prevent moisture ingress. Firstly, use a sealant that is compatible with the conduit material. Secondly, apply sealant to all joints and connections in the conduit system. Thirdly, ensure that the sealant is properly cured before exposing the conduit system to moisture. Fourthly, inspect the conduit system regularly for any signs of leaks or damage. In regards to enclosures, selecting the correct one for an open-bottom junction box, consider these points. Firstly, choose an enclosure that is listed and labeled for the intended use. Secondly, select an enclosure that is made of corrosion-resistant material if the environment is wet or corrosive. Thirdly, ensure that the enclosure is large enough to accommodate all conductors, splices, and equipment. Fourthly, choose an enclosure with a cover that is securely fastened to prevent unauthorized access or tampering. Let's look at grounding and bonding in more detail for open-bottom junction boxes. Firstly, use a grounding electrode conductor to connect the enclosure to the grounding electrode system. Secondly, bond all metal components within the enclosure together using bonding jumpers. Thirdly, use listed grounding and bonding fittings and connectors. Fourthly, ensure that the grounding and bonding system is continuous and effective. As far as inspection and maintenance goes, it is recommended that electrical installations be inspected periodically to ensure that they are in good working order. Open-bottom junction boxes should be inspected regularly for any signs of damage, corrosion, or moisture ingress. Any necessary repairs or replacement should be made promptly. If any doubts arise, consult with a qualified electrical contractor or engineer to ensure the safety and compliance of the installation.